Hello, welcome again. Continuing with GATE 2014 Production Industrial Engineering paper, starting with question number 36. A CNC instruction G91 G01 X30 Y40 F100 commands the movement of tool along the path at a feed rate of 100 mm per minute. G91 incremental from a G01 linear interpolation. Okay. The feed rate of the tool in mm per minute along x-axis will be. So here the final point is at x30 and y40. So and the initial point is your 0, 0. Okay. So the distance traveled is your 50. Okay. So x30 y40 and it will be like that. Okay. And the feed rate along this 100 is your sorry, along this 50 is your 100 mm per minute. Okay. Now you have to calculate the feed along this x. Okay. Now feed along this 50 is 100 mm per minute. Okay. So by similarity of this triangle, uh, as these triangles should be similar because they are related to same path. Okay. So this is your feed, this is the velocity, okay, and this is the feed in the direction of that 50, okay, and feed in the direction in x in the direction of x is fx and direction is fy. So as these triangles are similar, so they can use similar kind of properties. So fx by 100 should be equal to x by 50, okay. So x is your 30, so fx is your 60. So answer is your 60. Next, next question 37. The elastic moduli of a fiber reinforced plastic composite and fibers are 200 GP and 400 GP respectively. The longitudinal fibers are taking up to 50% of load, assuming the area fraction equal to volume fraction, and the volume fraction of the fiber will be. So let A be the area of composite and AF be the area of fiber. Okay. And modulus of elasticity of composite is 200 GPa, and for fiber it is 400 GPa. Okay. If P is the total load applied to composite, okay, then it is given that the longitudinal fiber takes 50% of the load. So the the load taken by the fiber is P by 2. Okay. So as a matrix and a fiber form composite, okay, and they are in parallel. So the strain in fiber and strain in matrix and strain in composite will be same. Okay. So so PF is the load taken by fiber. So PF is equal to EF. P by A, sorry, the strain in fiber is PF by AF by EF, and strain in composite is P by A by E. Okay. So E for the composite is 200. Okay. And for fiber is 400. Okay. So putting these values we can find out, uh, and PF is your P by 2. Okay. So putting these values we can find out AF by A is equal to 200 by 800. So that is 1 by 4, that is 0.5. So the area ratio is your 0.5, 0.25. Okay. So the it is given that the area ratio is equal to the um, area fraction is equal to the volume fraction. So the volume will also be in same proportion. Okay. So AF by A is equal to BF by B. So answer is just 0.25. Okay. So we have to find out, the volume fraction of the fiber will be just 0.25. Okay. So the answer is 0.25. Next, the processing time and due dates of four independent jobs processed by a single machine in a shop are given in the table. Job 1, 2, 3, 4. processing time 4, 7, 2, 8, due date 6, 9, 18, and 15. Okay. The average lateness of the job in days following the shortest processing time, SPT rule is, so according to shortest processing time, uh, the first job should be third job, okay, this job, okay, and then the shortest processing time is for one, and then for two, then for eight, okay. So arranging in that order, so three, one, two, four. So this is two, this is four, this is seven, this is eight, okay, and due date for these is due date for 3 18, and for writing out these due dates, so due dates are 18, 6, and 9, and 15. Okay, so this will be completed after 2 days. Okay, so there will be after 2 days, so there will not lateness, and this will be completed after 2 plus 4, 6 days. Okay, so there is no lateness. Okay, similarly, this will be completed after 7 plus 4 plus 2, 13 days. Okay, but due date is your 9, so there will be lateness of 4 days. Okay, and this is four having the maximum processing time will be completed in 15 days. Summation of this, and it will be late by 6 days. So total lateness is 10, and number of jobs are 4. So this mean lateness is total lateness by number of jobs, or it is also called tardiness. The answer is 2.5. 10 by 4. 2.5. Next, the annual requirement of a raw material item is 10,000 units. The holding cost of inventory for the item is 80 paisa per unit per year, and ordering cost is rupees 40 per order. The order quantity presently is 800 units per year. Assume that there is no other cost. Which one of the following statement is correct? Option A, order quantity is optimal and total ordering cost is equal to total holding cost. B, the order quantity is optimal and total ordering cost is more than the total holding cost. C, the order quantity is not optimal and total order quantity is equal to total cost. The order quantity is not optimal but not, and total holding cost is less than holding cost. So annual requirement is this, okay, and holding cost is this, and ordering cost is here 40 per order. Okay. So if we neglect the unit cost, okay, then the total cost is here this. Okay, we have to optimize it because, okay, so ordering cost is the number of orders plus average quantity that can be held into holding cost, and the ordering cost is your number of order are uh, D by Q, and ordering cost is your O. Okay, and this is your average number of units that has to be held per year is your Q by 2. So and H is the holding cost. Okay, so if we want to minimize that cost, we will differentiate the cost respect to Q and find out the Q, and the Q is your 100. Okay, by differentiating it and putting it equal to 0, we find out Q. So Q is your 100. Now, uh, as the ordering quantity, ordering quantity is your 800 units per year. Okay, so this is not the optimum ordering, sorry, 800 given 800 the quantity given is your 800. Okay, so which is not the optimal quantity. So this is the optimal quantity is your 800. Okay, and for sorry 100, for 800 the ordering cost is your, if you put here here this is the ordering cost per order, so the number of order. Okay, so we put here Q as 800. Okay, then the ordering cost will be 10,000 by 100, 800 into 40. Okay, this is the number of orders and this is the ordering cost. Okay, and holding cost will be your 800 by 2 into 50, this is 13,000. Okay, so it means the holding cost is more than the ordering cost. To answer the holding cost, the quantity is not optimal and ordering holding cost is more than not optimal and holding total ordering cost it is not optimal and total ordering cost is less than the holding cost. Okay, answer is your B. Next, a single server queuing system arrivals are Poisson's distribution with a mean of 16 per hour and the exponential service time is 3 minutes per person on the average. What would be the expected number of persons in LQ for the Q discipline for the first come first serve FCFS and the last come first serve LCFS. Okay, so the arrival rate is your 16 per hour and service rate is your 3 minutes per person. It means 60 by 3 okay, person per hour. Okay, or 20 per hour. Okay. So the mean time, mean number in waiting, we know that that formula lambda. This is your lambda. This is your mu. So lambda square where the mu mentioned. So answer is that putting the values. You have to remember these formulas of queuing theory. Okay. So answer is your 3.2. Okay. So this is the mean number in waiting line or Q. It does not depend upon the first come first serve or last come last serve. Okay. So it is the same. Okay. So it will be mean number in waiting line or queue means same. Okay. It doesn't matter. So answer is 4. It is number in waiting line. Number in waiting line equal to your answer should be D.